Alright, so this problem here is on the 1.5 quiz. It's number 6. It's a rational expression, and we have a minus sign. We're subtracting them. And so what we need to do is first make sure we have a common denominator. So let's check it out and see. We have x squared minus 2x minus 15, and on the second one we have the same denominator. So if we have the same denominator, this problem ends up being quite easy. So actually, before we even go to that problem, say if we have just a simple fraction like 2 or 5, and we're subtracting, something like 1 over 5. The same concept that we're going to use for this problem is exactly what you see here. 2 minus 1, now remember we have a common denominator, so we can work with the tops. 2 minus 1, so that's just real simple. That's going to end up being 1/5. Now, if we had a different denominator, just simple fractions, we'll just do simple again. So we'll take that same 2 over 5, and we'll subtract, say 2 over 3. Different denominator this time. Okay, we can't, so we have to, there's another step involved. We've got to get a common denominator. And so for this one, we have a 5, we have a 3. An easy way to get a common denominator is just say, hey, well, this one needs a 3. So we're going to multiply top and bottom by 3. And this one over here needs a 5. So top and bottom by 5. And so we'll end up with 6 over 15. And that's going to be minus 10 over 15. And now that we have a common denominator, now we can work with that bottom, or excuse me, the tops. And so it's 6 minus 10, which is negative 4 over 15. And so these same concepts we're going to use with the rational expressions. Same exact thing, except this time we have some variables. And I know students hate variables, but this time we have some variables. So in the problem we have over here, so let's clear this up. So we have a common denominator, so we're good. So let's look at the tops. So we have x squared minus 7x. Now here we have a minus sign, so there's a minus sign there. And it is subtracting the entire numerator. So the most common mistake I see students make with this is they forget to distribute the negative. So we have a minus, and I'm going to put a parenthesis here just to emphasize that we're actually subtracting that whole thing. And I like to use parentheses here because what happens here is this large division sign, or fraction sign, it's also the same as division sign, that large division bar, fraction bar, is kind of separating the x minus 15, so it's acting like it's a separator, like a parenthesis. The parentheses just doesn't have to be written like that. So we're going to distribute the minus sign in. That's got to go to both. So it's going to go to the x and the negative 15. And so we have x squared minus 7x. That's going to be minus x. And then negative will make that positive 15. And some simple simplification here. Take the two middle terms, they're like terms, so we can combine them. So the numerator ends up being x squared minus 8x plus 15. And that is going to be over that denominator, that common denominator we had, x squared minus 2x, and see, minus 15. Okay. So now from here, now this is in a more of a traditional classroom. I do see students make this mistake. What they do here is they see that 15 and they see the 15 on the bottom and the numerator. They think they can cancel these out. That's incorrect. Now, if it was a fraction in and of itself, yes. But because it's attached here as part of this polynomial, you can't just automatically cancel those. Another one that they try to cancel are the x squareds. Can't do that because it's attached to the entire polynomial. The factors must be exactly the same at the top and bottom in order to cancel them. So let's see if we can simplify this. Are there factors of 15 that can get you 8? Are there factors of 15 that can get you 8? Well, let's think about that. Factors of 15. 1 times 15, 3 times 5. Oh, bingo, right there, 3 times 5. So 3 times 5 gives you 15, 3 times 5, or excuse me, 3 and 5 gets you 8. So the numerator can end up being x, and now I'm going to put minus 3, and then x minus 5. Now I know it's that way because if you take a look here, the last sign is positive, and if this last sign is positive, I know that my factors are going to have the same sign. They might not both be positive. They can both be positive or both be negative. And the main reason why that is because negative 3 times negative 5 is positive 15. Also, a positive 3 times a positive 5 is a positive 15. Now, the reason why I know it's negative is because this middle sign is negative. So, think about it. We have negative 3, minus 5 gives you negative 8, and then we have negative 3 times negative 5 does give you the positive 15. Okay, and so that's going to be all over. And now let's do the same thing for the bottom. So, this time the sign is negative. So we're going to have parentheses. Now, if that last sign is negative, I know that I'm going to have opposite signs. One's going to be positive, one's going to be negative. And so over here, one's positive, one's negative. And it's got to be that way, because there's only one way to have a positive times a negative to get a negative. That's it. There's no other way. So it's a matter of what are the numbers that we're going to put there. So we have x and x. Well, that one's easy because this first term is x squared. There's only one way to break that up. And so now, since that last sign is negative again, the signs are opposite, so that means I got to subtract to get my negative 2. And so that happens to be right here. 3 and 5 will be used again. Now, that's a negative sign, so naturally you got to think the bigger number's got to be negative. So that's going to be x minus 5, and then over here is going to be x plus 3. Alright, so from here, now one other thing is, let's just make sure it says perform the following subtraction. Select the correct choice below and fill in the answer box to complete your choice. So for this one here, it says, oh, okay, good. It says simplify your answer. And that's what I'm going to show you. I'm going to show you how to simplify your answer. Now, above here, before we said that students try to cancel the 15s. They try to cancel the x squareds, but you can't. When you have addition or subtraction, the factors must be the same. And so, right here, that factor is exactly the same as that factor. And the key here is, in between, you now have multiplication. Now, if there was addition between those parentheses, you can't do that. But now that we have multiplication, now you can cancel those factors. Now, one interesting thing here is, over here, it says x cannot equal negative 3 and 5, but the second choice says x cannot equal negative 5 or 3. Well, where does that come from? Well, this is where it comes from. You have to look at the denominator. Now remember, you cannot divide by 0. And so if I look at the denominators here, and now you have to go with the original. You can't just look at what's left over. So I had an x plus 3. I have an x minus 5. And so the question is, what will make each one of those 0? So x plus 3 equals 0. So subtract by 3. From each side you have x as negative 3. And then over here, x minus 5 is 0. And then you add 5 to each side to get x equals 5. And I know I solved that, But the thing is, what I was trying to find was what will make each of those parentheses 0. Because if you think about it, this x plus 3, if that parenthesis was 0, it doesn't matter what the other parenthesis is. It doesn't matter. 0 times anything is 0. And then over here, if the x minus 5, if that parenthesis was 0, it doesn't matter what the first parenthesis is. Anything times 0 is 0. And so, the two values that would make the denominator 0, we have two possibilities. If x was negative 3, or if x was 5. And that's why, over here, it says x cannot equal. So, let's write out our final answer here. Our final answer is going to be x minus 3 over x plus 3. And then we have to make sure we add this in, but it's already there for us. But we have to make sure we say x cannot equal negative 3 and 5. So let's just recap this real quick. What we did here, first off, was since we already had a common denominator, it made it easy. We didn't have to get a common denominator. We already had it. So we distributed that negative. So we distributed negative, and x became negative. Then we had a double negative to get to 15. We simplified the terms to get negative 8x. And so from there, well, the problem said simplify. So right over here, so what we did here was we wanted to make sure we factored. Now sometimes these can't be factored. And if they can't be factored, well, you can't do anything else to them. But these ones here, they definitely can be factored. They definitely can be factored. And so we ended up factoring them, and we did find that in the top and bottom we had the same factor. And once you have the same factor, you definitely can cancel them out. And so that was the simplifying part. But we wanted to make sure we fully answered the question. And when it comes to rational expressions, there's sometimes there's answers that will not work. And you usually find that in the denominator here, and it's where the denominator is equal to 0, because we can't divide by 0. And so there's two values where you cannot divide by 0. It's negative 3 and positive 5. And so that ended up to be the final answer for this particular question. Now, when you go work through these quizzes, a lot of the points always, or not the points, but the values usually change. But this at least gives you a good example to work through for this problem.